Hi everyone, you are welcome to DML Physics Concepts. Kindly subscribe to this YouTube channel. Make sure you like this video and you can share to your friend. And at the same time, you can pass comment in the comment section. Thank you for staying with us. Today we'll be looking at another topic which are tied to current electricity. And when talking about current electricity, this is opposite to the static electricity. What is static electricity? Static electricity simply means electricity at rest. Static electricity is also the study of charge at rest, while current electricity is the study of charge in motion. So, having understand this one, then we must understand as well that in any electric circuit, there is a need to measure some things. Number one, we measure the current, and the SI unit for current is in ampere. Then number two, we measure the EMF or the potential difference, and the EMF and the potential difference both are measured in volts. Then number three, we measured the resistance, and the resistance is measured in ohms. So once again, I'm saying that in an electric circuit, there are three things we measured. As rightly said, we measure the current I, we measured the EMF or the potential difference, and we measure the resistance in that circuit. But before we proceed on that, there are some terms I want you to understand. I've rightly defined what current electricity is all about. I said current electricity is talking about electricity in motion. It is the study of charge in motion. Then let's look at another thing. What is electric circuit? So electric circuit is the path of flow of charge in a circuit. It is the path of flow of charge. Electric circuit is the path of flow of electric charge. So you can put it that way. Electric circuit is the path of flow of electric charge. So let's look at another parameters that we must be able to define their terms. So let's look at the next one. Current. Now, what is current? You must be able to define current. Current is the time rate of flow of charge round a circuit. Current is the time rate of flow of charge round the circuit. We'll still go into that later. Then what is EMF? EMF is otherwise called electromotive force. And how do we define electromotive force? This is the total work done in moving 1 coulomb of electricity around the circuit. Remember, charges moves around the circuit. As we define electric circuit, the paths of flow of electric charge. And what moves? What is the motion? Charge in motion. So the total work done in moving 1 coulomb of electricity or 1 coulomb of charge around the circuit is called electromotive force. Then we also have potential difference. Potential difference is talking about the work done in moving coulomb of charge from one point to another within the cell. We'll look into this later. And then we have the third parameter, which is resistance. And what is resistance? Resistance simply means opposition, from the word resist. Resistance is talking about opposition to the flow of current in a circuit by a resistor. So in a circuit, there is an opposition to the flow of current in a circuit. That is why when there's power supply and you plug your iron, you discover that the current drops. Why? Because there is a resistance to the flow of current in that circuit. So there will be a voltage drop, and you will notice that there is a voltage drop. The reason why there is a voltage drop is because there is a resistance in that circuit, and that resistance is your iron, the present iron that you plugged. So that's what we are talking about. So there is a relationship between these parameters we have defined: current, EMF, and resistance. The relationship, V represent the potential difference, I represent the current, and R represent the resistance. So the relationship between these three is defined or is explained by a man which is called George Simon Ohms. So George Simon Ohms in 1826 found by experiment that there is a relationship between current flowing through a good conductor and the potential difference across it. And that is why we have what is called the Ohm's law. And what is Ohm's law? Ohm's law states that the current passing through a metallic conductor is directly proportional to the potential difference across its end. provided temperature and other physical conditions such as pressure are kept constant. So let me recap. Ohm's law states that the current passing through a metallic conductor is directly proportional to the potential difference across its ends, provided temperature and other physical conditions of the conductor are kept constant. So every student must be able to understand the concept of Ohm's law, because the concept of this Ohm law, aside stating the law, you must also understand the concept of this law, and that will help you to understand better. Remember, Ohm's law, the way it was stated, there is a condition: provided temperature and other physical conditions are kept constant. It means if temperature and other physical conditions of the conductor are not kept constant, then Ohm's law will not be obeyed. So which means there are certain instances whereby Ohm's law will not be obeyed. That is, it will not be obeyed provided certain conditions of the conductors are not met. Then at the same time, there are some material that behaves those material behaves in such a way that they do not obey Ohm's law. So as we progress in this class, I will tell you examples of those materials that do not obey Ohm's law. So let's write an equation based on this statement. Current is proportional to the potential difference provided the temperature is kept constant. So let's look at a formula for that. So from that statement, since current is directly proportional to the potential difference, which is V. So if I is proportional to V, remember I represent current and V represent the potential difference. So otherwise we can also say V is proportional to I. So if V is proportional to I, we remove this proportionality constant, we introduce an equal sign, and at the same time introduce a constant. So to introduce a constant, then we are going to have V equals to I R, where R is the constant. So what we are saying is that in a given electric circuit, when the resistance of that circuit is kept constant, that is when the resistance of the circuit is not changing, then as voltage increases, current will also increase. That is what proportionality means. And at the same time, as voltage reduces, current is going to reduce as long as the resistance is kept constant. So let's work around this formula. So to understand the concept of the relationship between current, voltage, and resistance in a circuit, then we need to understand the concept I've put on the board. So look at it. Recall that we said that Ohm's law states that the current passing through a metallic conductor is directly proportional to the potential difference, provided resistance and every other physical conditions or temperature and many other physical conditions of the conductor are kept constant. So we have this formula: V equals to IR. So when the R is constant, so what happens is that V is proportional to I, as we have it in this expression. So it means as V increases, I increases, whereby this R is kept constant. Now let's do the second case. At constant V, when the voltage in the circuit is kept constant, so since V equals to IR, so let's make I the subject of the formula. I is going to be V over R. So if we look at the relationship between this formula, we can see that I and R, they are inversely proportional to each other. So given that V is constant, then I is inversely proportional to R, which means when the voltage in the circuit is kept constant, by the time you start increasing the resistance of that circuit, the current in the circuit will reduce. So at a constant voltage, increase in resistance will reduce to decrease in current. Or you can say increase as I increases, R keep decreasing. Then number 3, at constant high. So when current is constant in a circuit, what happens? We still have V equals to IR. So if I make current the constant, so it means V is proportional to R. So V is proportional to R. So if I is kept constant, then V is proportional to R. So these conditions and this concept must be understood and will be applied in the practical class. So you must understand the relationship between voltage and current and resistance in a circuit. That is, if you are dealing with a circuit and we decide to make voltage constant, then you must be able to know the relationship between the current and resistance in that circuit. So it means if voltage is kept constant, as you begin to increase the resistance of that circuit, the current in that circuit will be reducing. So let's look at the circuit a diagrammatic representation of a circuit and say how a circuit looks like. So the diagram we have on the board is a representation of a circuit. So this line, all these lines, is talking about the path through which current flows. Current will always flow from the cell. So the total work done in moving the charges around the circuit is what we call the EMF. So the EMF is residence in the cell here. So this is the cell. So let's look at the symbol here. So we have the voltmeter. The V is the voltmeter. There's the symbol of the voltmeter. Then we have the resistor. This is the symbol of the resistor. This is the symbol of the ammeter. An ammeter is to measure current in the circuit. The voltmeter measures the potential difference across the resistor. And this is how the circuit is always connected when we are dealing with electric current. The ammeter is always connected in series with the circuit. Series means must be in a line with the circuit, while the voltmeter will always be connected in parallel across the resistor as we have it here. So these are an example. So what we are saying is that in a given circuit we can decide to make V constant. So if this voltage is constant, now what's going to happen to if you make this EMF constant, so we must know what is going to be the relationship between the current and the resistance. If I make resistance constant, you must know the relationship between the current and the potential difference and so on. And that's what we explained in the previous class. So you need to get that. So this concept is very important for you when we are dealing with Ohm's law. And I said that Ohm's law, there is a condition attached. It said provided is a condition. So which means there's what we call limitations to Ohm's law. And what are we talking about? Now, Ohm's law holds for metallic conductors. Ohm's law will only hold for metallic conductors and certain other materials at constant conditions such as temperature and pressure. So the temperature must be constant, the pressure must be constant before Ohm's law can be obeyed. And at the same time, the resistance of some conductors will change if placed under tension or bent into a loop. So that is why it's very important that there are some material that does not obey Ohm's law. When you bend them into a loop or you put them under tension, their resistance begin to change, and because of that, they started behaving. An example of material that do not obey Ohm's law, we have the radio valves, we have the transistors, we have semiconductors, we have rectifiers, we have neon gas, we have acids, we have diodes, we have thyristor, we have capacitor. So let me put them on the board so that you can see the list of the materials that do not obey Ohm's law. So the materials that do not obey Ohm's law, those are the list that are put on the board. We still have more of them, but I just give you 9. Then there are still many more. So all those materials, they are referred to as non-ohmic conductors. They are non-ohmic conductors because they do not obey Ohm's law. Remember, Ohm's law is a conditional statement that provided potential, you said the current passing through a metal is directly proportional to the potential difference provided certain conditions are met. So if those conditions are not met, then such material will not obey Ohm's law. And we have some material that they will not meet that condition, and that's why we call them non-ohmic conductors. So thank you for enjoying this class. Next class we'll be looking at resistance in series, resistance in parallel in a circuit, and then we'll begin to move into some calculations. Thanks for joining this video. Kindly like this video, subscribe to this YouTube channel, and you can search for me at Olayo Oludare 4435 on YouTube. Thanks, and God bless you.